Out on the open ocean, a United States Navy destroyer is a powerful symbol of American strength. It's packed with high-tech sensors and long-range missiles, ready to handle threats from miles away. But, what happens when something actually gets through? When an enemy missile or maybe a swarm of drones slips past those outer defenses, things get personal very quickly. This is where the ship's final line of defense comes into play. It's a job so critical, so last minute, that you just can't leave it to chance. It requires a system that is fast, automatic, and honestly, brutally effective. This is the job of the Close-In Weapons System, or CIWS. The CIWS is a self-contained automated gun system that sailors affectionately call R2D2, with a Gatling gun. And honestly, the nickname fits. It's a white domed unit that sits on the deck, constantly scanning the horizon for anything that shouldn't be there. Its sole purpose is to protect the ship and its crew from immediate last-second threats. Think of it as the ultimate bodyguard, standing guard around the clock, ready to spring into action when everyone else's plans have failed. It doesn't negotiate and it doesn't hesitate. Its job is to put a wall of metal between the ship and whatever is coming to harm it. When you look at a modern warship, you see a complex machine with hundreds of sailors, each with a specific role. But the CIWS handles its job almost entirely on its own. It has its own radar to find and track incoming targets, its own computer to evaluate the danger, and its own gun to eliminate the threat. This automation is not just a convenience, it's a necessity. Modern anti-ship missiles travel at incredible speeds, often skimming just above the waves. A human simply cannot react fast enough to stop them. The CIWS, however, can go from detection to destruction in the blink of an eye. The system is a testament to smart, practical engineering designed for the dirtiest job on the high seas, point-blank defense. For decades, the Phalanx CIWS, with its 20mm Vulcan cannon, has been the standard. It is mounted on nearly every United States Navy surface ship and is trusted by navies around the world. Its presence provides a crucial layer of security, a final defiant stand against a determined enemy. It's the one system you hope you never have to use, but the one system you're incredibly thankful to have when things go sideways. It's a dirty job, but someone, or something, has to do it. So how exactly does this thing work? It's a marvel of automation. The CIWS operates in several modes, but its most critical function is fully automatic. The system's own search and track radar sweeps the sky and sea around the ship. When it detects an object moving at high speed on an intercept course, its internal computer instantly analyzes the target's trajectory, speed, and size. It determines if the object is a threat. If the computer decides the ship is in danger, it takes over. It doesn't wait for a sailor to push a button. It acts on its own because, honestly, in these situations, a fraction of a second can be the difference between safety and disaster. Once a threat is confirmed, the CIWS locks on. The white dome swivels with unnerving speed, aiming the 6-barrel M61 Vulcan cannon directly at the incoming target. This is the same type of gun used on fighter jets, known for its incredible rate of fire. The system can unleash a torrent of 20mm tungsten core bullets at a rate of 4,500 rounds per minute. That's 75 bullets every single second. It doesn't shoot to disable the missile, it shoots to obliterate it, creating a dense cloud of projectiles that the threat just can't possibly fly through without being shredded into harmless fragments. It's a simple, brutal solution to a very complex problem. This capability was put to the ultimate test in the Red Sea. In January 2024, the crew of the USS Gravely found themselves in a real-world nightmare. A Houthi anti-ship cruise missile broke through the ship's other defenses and was screaming toward them. With the missile just a mile away and seconds from impact, the ship's Phalanx CIWS roared to life. It automatically tracked the incoming threat and fired, destroying the missile just before it could strike the ship. This was not a training drill. It was a real-life engagement that saved the ship and the lives of over 300 sailors. It proved that after decades of service, the CIWS works exactly as designed. The modern versions of the Phalanx, like the Block 1 Bravo, are even more capable. They're equipped with a forward-looking infrared sensor, which allows the system to visually identify targets. This helps it distinguish between enemy craft and friendly ones, and makes it effective against small surface boats and even helicopters. However, the system isn't perfect. Its magazine holds about 1,550 rounds, which sounds like a lot, but at 75 rounds per second, it provides only about 20 seconds of continuous firing. After that, it needs to be manually reloaded, a process that takes time. Time you might not have if you're facing a swarm of drones. Protecting a billion-dollar warship is an expensive business. The United States Navy has a layered defense strategy, which means it has different tools for different jobs. For distant threats, a destroyer can launch a standard missile, like an SM-2 or SM-6. These are incredibly sophisticated weapons that can intercept targets from over 100 miles away. They're a technological marvel, but that technology comes with a hefty price tag. A single one of these missiles can cost over $2 million. Firing one is a serious financial commitment, one you only want to make when absolutely necessary. Now let's look at the recent conflicts like the one in the Red Sea. The threats are often not sophisticated enemy warships but relatively cheap drones and older cruise missiles. Using a multi-million-dollar interceptor to shoot down a drone that might have cost only a few $1,000s is like using a sledgehammer to kill a fly. It works, but it's not exactly a sustainable strategy. You can quickly burn through your limited and expensive missile supply. This is where the CIWS proves its value not just as a weapon, but as a smart piece of financial planning. It offers a much more cost-effective solution for close-in threats. Firing the Phalanx CIWS is by no means free. Those 20mm tungsten rounds cost about $46 each. At a rate of 4,500 rounds per minute, the system is spending around $3,500 every single second it fires. That sounds like a lot of money, and it is. But compare that to the $2 million price of an interceptor missile. You could fire the CIWS continuously for almost 10 minutes for the cost of a single SM-2. When you're facing multiple low-cost threats, the math becomes very clear. The CIWS is the bargain option for last-ditch defense. This economic reality is at the heart of why the CIWS is so beloved by naval commanders. It allows them to save their expensive long-range missiles for the truly high-end threats they were designed for, like advanced enemy aircraft or sophisticated anti-ship missiles. For the drones and small boats that try to get up close and personal, the CIWS provides an effective and much more affordable answer. It's a tool that not only saves ships and lives, but also saves taxpayer money, ensuring that our naval forces can sustain a long fight without breaking the bank. It's about having the right tool for the job, every time. The world of naval warfare is always changing, and so are the threats. The rise of cheap, unmanned drone swarms presents a new kind of challenge. A single CIWS might be able to stop one or two, but what about 20? Or 50? The current Phalanx system, with its limited magazine and relatively short range of about 1 mile, could be overwhelmed by a saturation attack. This is why the Navy and its industry partners are already looking ahead, working on the next generation of close-in weapon systems to keep our sailors safe in the future. One of the most promising new developments is the Bofors 40 Mark IV Canon. This is a 40mm gun, a significant step up from the 20mm cannon on the Phalanx. A bigger bullet means more range and more stopping power. The Bofors can effectively engage targets up to 3 miles away, giving the ship's defenders more time to react. More importantly, it fires incredibly advanced ammunition. These are called 3P rounds, which stands for pre-fragmented, programmable, and proximity fused. This means each shell can be programmed to explode at the perfect moment, creating a cloud of 1,100 tiny tungsten pellets. This programmable ammunition is a game-changer against drone swarms. Instead of having to hit each drone directly, one 40mm round can create a wide kill box in the air, potentially taking out multiple drones at once. BAE Systems, the company behind it, estimates that a single load of 100 rounds could defeat up to 50 drones or a dozen cruise missiles. This level of efficiency would allow a ship to defend itself against swarm attacks far more effectively than it can today, all while preserving its expensive long-range missiles for more serious threats. It's about working smarter, not just harder. Perhaps the cleverest part of this new system is its design. BAE has developed a containerized version, which they call a palletized CIWS. The entire weapon system, gun, sensors, and control station, is built into a standard shipping container. This means you can load it onto almost any ship with deck space, from a massive aircraft carrier to a lightly armed supply vessel, and have it up and running in a matter of hours. This flexibility could dramatically increase the defensive capabilities of the entire fleet. In the end, the job remains the same: protect the ship at all costs. From the trusty Phalanx to the future Bofors, The CIWS is the final, furious answer to anyone who gets too close.